Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we are going to study about hot wire anemometers, which are used for the measurement of flow rate of the liquids. Here we will study its principle of working, its construction, its types and its advantages, disadvantages and applications. So let us start with our topic. Hot wire anemometers, they are mainly used in the research applications for the measurement of fluid flow rate. So to measure the velocity of the fluid or liquid which is flowing in a pipe in the industries or in the pipe or in laboratories or in research applications, there we use the hot wire anemometers. Now let's see the principle on which the working of the hot wire anemometers is based. The principle of working is that when a heated wire is placed in a fluid or in a fluid which is flowing in a pipe, so the heat is going to get transferred from that heated wire to the fluid. Okay, and the amount of heat transferred is a function of the flow rate of the liquid. So this principle is being used in hot wire anemometers. Here also we will have a heated wire. That heated wire is placed in the stream of the fluid, in the fluid stream or the fluid which is flowing in the pipe. So when the fluid it flows through that heated wire is going to lose its temperature. Okay, so by measuring the change in the temperature of the heated wire, we can measure the flow rate of the fluid. So when an electrically heated wire is placed in a flowing gas stream, heat is transferred from the wire to the gas and hence the temperature of the wire reduces. It's not necessary that we are having a flowing gas stream only. We can have a liquid stream also, a fluid stream can also be there. So if it is a gas, then heat is transferred to the gas. If it is a liquid, then the heat is transferred to that liquid. So in both the cases, heat is transferred from that electrically heated wire to the fluid or the gas, and due to this heat transfer, the temperature of the wire reduces. So by measuring this reduction in the temperature, we can measure the flow rate of the liquid or the gas. Now how we are going to measure the temperature changes? Because temperature is reducing, so resistance is also changing. Okay, so either we can directly measure the changes in the temperature or we can measure the change in the resistance which is caused due to the change in the temperature. So So change in temperature causes change in resistance, and this change in resistance becomes a measure of the flow rate. So that is the working principle or operating principle of the hot wire anemometers. Okay, so hot wire anemometers, in that a heated wire is used. Heated wire is placed in the flowing stream. Due to that, the temperature of the heated wire changes because it has given its heat to the fluid or the gas, and because of the temperature changes, resistance of the wire also changes, and resistance changes, so current also changes. So by measuring the change in resistance, we can measure the flow rate. Now let's see the construction of the hot wire anemometers. If we talk about the main parts or main components of the hot wire anemometers, then first component is the heated wire. Then we have a ceramic tubing. Then conducting wires are there, and leads are there to connect this hot wire anemometer to the Wheatstone bridge. So these are the main components or main parts of the hot wire anemometer. Let's see its diagram. So this is the construction, or this is how the hot wire anemometer look like. Here the fluid is going to enter from this side. Here we are having two conducting wires. Okay, in between them means this is the heated wire. So this heated wire is going to lose its heat to the fluid which is flowing here. Here we are having the ceramic tubing, and in between it we are having the ceramic cement. Then to this conducting wire, leads are connected, and these leads are going to connect this conducting wire to the bridge circuit. So if the fluid is flowing here, so the conducting wire is going to lose its heat, or its temperature is going to change, or we can say its resistance is going to change. So this change in resistance is measured by using the Wheatstone bridge. Okay, so this was the construction or the main parts, and in that we see that we are having the conducting wires, the leads, and these leads are taken from the conducting wires to the bridge circuit. Conducting wires, they will act as the heated element or the hot wire, and this hot wire is going to change its resistance with this fluid flowing here. Okay, and this change in resistance, because these conducting wires are connected with the leads, and these leads are going to connect this conducting wire to one of the limbs of the, or one of the arms of the Wheatstone bridge, and with the help of Wheatstone bridge we are going to measure the change in the resistance of this hot wire. Now let's see the working of the hot wire anemometers. The working of the hot wire, there are two methods for the measurement of the flow rate or the fluid velocity by these hot wire anemometers, and these two methods are: one is the constant current method, and other is the constant temperature method. Okay, so first we will study the first method, that is the constant current method for the measurement of flow rate. Let us first see the circuit diagram for this constant current method. So this is the circuit diagram for the constant current method. This is the pipe in which the fluid or the gas is flowing, and in this pipe the the wire is being kept here. Okay, or we can say that this is the hot wire anemometer, the conducting wires of it. Now with the help of leads, it is connected in one arm of the Wheatstone bridge. Wheatstone bridge is a bridge which is having four arms: AB, BC, CD and DA, and in these four arms the resistances are being connected. So three resistances are already connected, and one of the resistance is replaced by the hot wire. Okay, now to this Wheatstone bridge a rheostat and a battery is connected to change the current through this bridge circuit. And for checking the balancing of the Wheatstone bridge, we are having a galvanometer connected in between. So this is the constant current method arrangement. Let's see that how this method works for the measurement of flow rate. First of all, a constant current is passed through the sensing wire. Now this constant current is passed with the help of the bridge circuit. Constant current is flowing, it means that the voltage across the bridge circuit So we are saying that constant current is passing through the sensing wire, means that across the bridge circuit a constant voltage is maintained or its voltage is not varied. Okay. So when this bridge circuit is having constant voltage, so in each arm, or we can say that this bridge circuit is under the balance conditions. So when the bridge is balanced, means that the voltage drop in both these arms is equal. Okay, that is AB and AD arms, they are having same potential drop, and BC and CD arms, they are also having the same potential drop. So voltage is not varied, and if voltage is not varied, it means that constant current is being flowing through the wire. Now when the fluid, it starts flowing in this pipe, so due to the flow of the fluid, the temperature of this wire is going to decrease, because this hot wire is going to lose some heat to the fluid. Okay, so due to the loss of the heat, the temperature of this hot wire is going to reduce. So due to the flow of the gas or the liquid, the heat transfer takes place, and this heat transfer takes place from the sensing wire to the flowing gas, and due to this heat transfer there is a change in the temperature. Okay, this temperature is going to reduce, and due to the reduction in the temperature, the resistance of the wire also changes. Now due to the change in the resistance of the wire, the galvanometer, which was initially at the null position, means it was indicating the zero value, so that is going to deflect. Okay, because due to change in resistance, current is also going to change, and if current is changing, voltage is changing, and due to that the bridge is going to get unbalanced. Earlier it was under the balance conditions. Okay, galvanometer was showing us null deflection, it was at zero position. It means that the bridge is being balanced, but due to the temperature changes and the resistance changes of this wire, due to that the unbalancing of the bridge occurs, and this unbalancing is reflected by the deflections of the galvanometer. So due to resistance changes, current also changes, and galvanometer is going to deflect, and this deflection of the galvanometer is a measure of the flow rate of the fluid or the gas. Okay. So this method is called the constant current method, because the first thing we have done is to maintain a constant current through this bridge network, and we are maintaining that by providing the constant voltage. Okay, voltage is not varied here, and rheostat and battery conditions, they are maintained, so bridge is under the balance conditions. And this hot wire, if it when it transfers the heat to the fluid or the gas which is flowing in the pipe, so due to that the resistance changes and the current changes, and unbalancing of the bridge occurs, and due to that the deflections of the galvanometer, they occur, and those deflections are proportional to the heat which is transferred to the fluid, or we can say the flow rate of the fluid. So in this way, by using the constant current method, we can measure the flow rate of the liquid or the gases. Now the second method was the constant temperature method. Let's see the arrangement of the circuit diagram for this method also. So this is the circuit or arrangement for the constant temperature method. So here also we are having the pipe in which the fluid or the gas is flowing. This is the hot wire anemometer. The sensing wire is placed, and this sensing wire is linked as one of the arms, or is connected as one of the arms of the Wheatstone bridge. Now here the other three arms are having the resistances R1, R2 and R3. Then we have a battery and rheostat to vary the current through the bridge circuit, and this one arm where this sensing wire is connected, so along that wire also a voltmeter is connected, so that we can measure the voltage drop across this arm. Okay, galvanometer is there to show the null deflections or for the balancing of the bridge. Let's see that how this method works. Again, the anemometer is kept in the gas stream or the fluid stream. So the hot wire anemometer, it is kept in the fluid stream or the gas stream whose fluid rate we want to measure. Now the current is initially passed through the wire. Now again, due to the fluid flow or the gas flow, this hot wire is going to lose its temperature because heat is transferred from this hot wire to the flowing fluid or the gas. Now due to the heat transferred, there will be a change in the temperature, there will be a change in the resistance, and due to resistance change, current also changes. Now here our motive is to keep the current same. Okay, so we will try to keep the changes in this circuit as 0. Okay, so if resistance is changing, there will be a current change or there will be a potential drop changes occurring in this bridge circuit. Now we will try that this galvanometer, which was earlier at the null condition or the 0 position, there will be no deflection in this galvanometer. Okay, and for that no deflections, we are going to vary the current or the voltage value. Okay, and the amount of current or voltage which is being varied to bring this galvanometer to the null conditions is measured with the help of this voltmeter, and this difference in voltage is a measure of the flow rate of the liquid. So here our motive is to keep the galvanometer conditions to be 0 or null in both the situations. So due to the flow of the liquid or the gas, the heat transfer takes place from the sensing wire to the fluid, and due to that there is a change in the temperature, and this change in temperature causes the change in the resistance. Now here our principle is to maintain this temperature and the resistance as constant, and because we are maintaining the temperature as constant, that is why this method is called the constant temperature method. So here the principle is to maintain the constant temperature. That is why this method is called the constant temperature method. So this temperature and resistance, they are maintained at constant level by maintaining the current in the bridge circuit. Because due to the fluid flow, the current and the temperature and the resistances are changing, and due to that the current is also changing. So our motive is to keep the current also as constant, and due to the change in the resistance, because temperature is decreasing, so resistance is also going to change, and due to the change in resistance here, how we can do that, we are going to bring the galvanometer again to the null conditions. We want that this galvanometer should be at the balancing position so that this bridge is balanced. Okay, now the additional amount of voltage or current which we have to provide here to bring this bridge to the balance condition is measured by the voltmeter. Okay. So the current through the sensing wire is increased, and this increase in current is measured by the voltmeter, because when we are increasing the current, voltage is also changing, and voltmeter can measure the changes in the voltage. So the electric current which is required to bring back the resistance and temperature to its initial conditions, they are a measure of the flow rate of the gas. So the readings which we are getting from the voltmeter, that voltmeter can be calibrated to directly give us the readings of the fluid flow. Okay. So this voltmeter is calibrated to give the flow rate readings directly. So here in this method, we are trying to maintain the temperature and resistance as constant, and the amount of current which we require to maintain this condition is the measure of the flow rate. Earlier in the constant current method, because due to the temperature and resistance changes, current was changing, we were measuring the changes in the current. Okay, we were trying to keep the current as constant in the first method, and in the second method we are trying to keep the temperature as the constant. So these are the two methods through which the hot wire anemometers can be used to measure the flow rate of the liquids or of the gases. Now comes its advantages and disadvantages. The advantages of hot wire anemometer is that is cost is relatively low, so they are cheap. Also their frequency response is high, Also their sizes is small, so measurement is very fast. Okay, measurement volume is also reduced. Good spatial and temporal resolution. Resolution means that the minimum amount of flow rate that can be measured by it. So it is having good spatial and temporal resolution. Also temporal flows can the turbulent flows, they can be easily measured with the help of them. Turbulent flows means that the flows in which are having very high turbulence, very high changes are taking place in it. Okay, flow rate variations are taking place at a very fast rate. So turbulent flows can also be measured. Also its accuracy is good. Signal to noise ratio is low. So disturbance problem is less in this. Also installation of these hot wire anemometers is very easy. So these were the advantages. Now comes its disadvantages. Now first disadvantage is that the liquid flows, they can contaminate the probes of the hot wire anemometers, and due to this contamination the anemometer is going to give us the wrong results, inaccurate results will be there. Probe breakage can also occur, the probe can also break in this, so that is also a disadvantage. Also noise due to the circuit elements. And noise due to the circuit elements and also the radio frequency signals in the surroundings, they can also affect the readings. Also temperature changes. If in the fluid there are some temperature changes, then that is also going to affect the result of the measurement. Also, as I have said that it can be used for the measurement of turbulent flows also, but this turbulent flow intensity, it is restricted to low and medium values only. So these are the disadvantages of the anemometer. Next come its applications. So it is used for the flow rate measurements of liquids as well as gases, and as I have said earlier that it is most probably used in the research applications. So in research applications, it is used to study the flow rate of the liquids and gases which is changing under, which is rapidly changing. Okay. So these were the applications of the anemometers. So in this video we studied about the hot wire anemometer, which is used for the measurement of fluid flow rate. Here we studied its principle of working, we saw its construction, we saw the two methods which are used for the measurement of flow rate, the constant current and the constant temperature method, and in the last we saw its advantages, disadvantages along with its applications. So I hope that this topic is now clear to you. Thank you.